So what's up with humans being trichromats, meaning we have 3 color receptors in our eye, when most mammals only have 2? They're dichromats. And how is this related to the fact that color blindness is more common in men than women, whereas tetrachromacy, having 4 receptors in your eye, is more likely to be in women than men? Well, it all starts with the dichromatic sensors that we see in most mammals. One for short wavelengths, or we call it kind of blue, and the other for long wavelengths, which we roughly call red. And it all really hinges on that one we call the red or long wavelength receptor. Because at some point during our evolutionary history, that red receptor split in order to allow us to detect more subtle changes in those longer wavelengths. And there are a couple theories as to how specifically this was advantageous, one being that separating greens from oranges and reds allows us to identify which foliage is good to eat, and the other points out that reddish hues in our skin allow us to detect mood in another person, and you need those 3 receptors to really start to define those different hues. And regardless of the specific reason, that longer wavelength cone eventually split into 2. One that we now call red and the other which we now call green or medium wavelength. And the genetic code for those long and medium wavelength cones is on the X chromosome, meaning those with one X and one Y chromosome only get the one copy from that parent. In contrast, the short wavelength receptor is coded on chromosome 7, which you get copies of from both parents. For that reason, it's much more likely to see variations in those long and medium wavelength receptors than it is on that short wavelength one. If that variation brings those receptors closer together, you get standard color blindness, most commonly again seen in men. But if instead you somehow get sort of 3 different cones, you end up with tetrachromacy like I talked about in that last video. And that's also why forms of color blindness where that short wavelength or blue cone is damaged are incredibly rare, because again, there is more redundancy in coding for that than there is for the long and medium wavelength ones. So there you have it. If you got any other questions, as always, throw them in the comments below.